Today we're going to start our discussion on the different types of chemical reactions. And so we're going to look at two specific reactions today, the combination reaction and the decomposition reaction. So let's start with the combination reaction. So if we have a combination reaction, it's also, you may see it known as a synthesis reaction, depending on what textbook you use. Basically, they mean the same thing. So with the combination reaction, it sounds, what's going on exactly as it sounds. So we're going to take two or more reactants, and we're just going to combine them to form one product. And that's the important thing. So when we look at a combination reaction, we're only forming one thing. And so let's take a look at a common combination reaction. And so here's a video of a common combination reaction. With this video, what we're going to see is the reaction of magnesium metal with oxygen gas. So here's our magnesium metal, right? Shiny, malleable, it's flat, it's ductile, we can pull it in, right? And so it has all those properties of a metal. It's a fairly soft metal, as you can see. And so, but if we take this, it has one really special property. If we take it, we supply some activation energy to it, then we can get this very, very kind of robust reaction, right? So it's obviously an exothermic reaction. It's producing lots of light, and all we're doing is burning the metal, right? So and we're burning it in the presence of oxygen, and so we're making something new. And so you can see kind of hanging on at the very bottom that new substance that's being made right there where the arrow is. That substance is magnesium oxide. And so one thing that you can see is now we're producing something new that has very different properties. It's, instead of metal, the color, it's actually white. It's very brittle. So what we'll see here is that it breaks really easily. And there you have it, that white metal. So that is an example of a combination reaction. So if we look at that reaction, right, what we had is our magnesium metal reacting with oxygen gas, so O2 diatomic, and we're forming magnesium oxide as a solid. And so here we had two elements getting combined to form a particular compound. Now, combination reactions aren't just limited to elements being reacted. So here we can see another example where in this case here we have two compounds that are being reacted, and those two compounds, when they react, are forming another compound, right? But basically we're taking them and merging them together. Okay, and so that's the basic gist. So the big thing is we have two reactants or more reactants, right? Because we could have potentially two or more reactants. Sorry guys. Two or more reactants. And we're only getting one product. That's the big thing to remember. Now, one thing I am going to ask you guys to do is to be able to predict the products of combination reactions. And so, but we're going to take a look at very simple combination reactions. And we're just going to look at combination reactions where we're forming ionic compounds. So we're just starting this on our chemical career, so we don't want to get too complex. But so if we can identify, we have a metal and a non-metal, we know that ionic compounds get formed by a metal and a non-metal, right? And so basically we're just going to take those, they get transitioned into their ion. So metals get transitioned to a cation, non-metals get transitioned into an anion through basically we're going to have a donation of electrons coming over that way, and we get our ionic compound being formed. Now, when we do this, we have to pay attention to charges and things like that, and which ones, if we have diatomic. So in this example, if we have potassium metal reacts with chlorine gas, we're going to have K+. Oops, I lied, because metals aren't ions yet. And so we're going to have potassium as a solid plus chlorine gas, and chlorine gas is Cl2, right? And now we got to figure out what the products are going to be. Now we can't just stuff them together because we have to pay attention to the charges, because that's how those ionic compounds are formed. So, but we know that potassium, when it forms an ion, will form a plus. We know that chlorine, when it forms an ion, will form a negative. And so over here, we're going to get KCl. Now, what's the problem with this, I would ask? And you guys would shout out, but Lambert, it's not balanced. And I would say, exactly, it's not balanced. So how do we balance? And then someone would shout out, hey, you need to put a 2 in front of the K, and we need to put a 2 in front of the KCl. So that's how we would balance. And then this right here would be our balanced equation predicting the product of KCl. So that's a combination reaction. Now, let's take a look at a decomposition reaction, right? So if we have a combination reaction, we put them together, and as you guys read, a decomposition reaction, we're basically taking that one reactant and we're breaking it down into 2 or more products. And so the big thing here is just the opposite, right? One reactant going to 2 or more products. So let's take a look at this. And so here, this is a pretty classical decomposition reaction. It's actually pretty cool. And so let's take a look at what's going on. So here's our one reactant, right? And notice that it is a nice orange called ammonium dichromate, nice orange color, and all kinds of good stuff. Now, what we're going to see, I'm going to speed it up a little bit. Now, we're going to put this on here. Now, to get this to start, we got to supply a little bit of energy called activation energy. And we're going to get there a little bit later in the unit when we start talking about energy transfers and endothermic and exothermic and how we can predict. But here you're going to see we're going to supply a little bit of energy. The big difference here is it's not a combustion reaction. It's actually a decomposition reaction. So here we have this. We're going to supply some activation energy here in a second, and then watch what happens. Nice little volcano going on. And notice that you can tell. How can you tell there's a chemical reaction going on? Well, hopefully you can see that the color change is very obvious, right? We're getting this black-green stuff. There's obviously energy being produced. And so you can see that that's going on. Obviously, too, there's some gas being given off because it's kind of, if we did this in a test tube, you could hear it. And so let's take a look at that reaction, right? And this one, wow, is here, right? Here's the formula for ammonium dichromate, right? And so in this case here, that thing is decomposing into 3 things, right? We get chromium 3 oxide, nitrogen gas, and water vapor. Now, this is a pretty complex. This is something that I wouldn't expect you to predict, right? But I just want to show you, like, we can get at least 2 or more. So here's an example where we're going to get 3. Another one where we can have calcium carbonate decomposing, right, into calcium oxide and carbon dioxide. So 2 examples of decomposition reactions. Right? Now, what I'm going to ask you guys to be able to do is we take a binary compound, and if we want to predict the products of that binary compound, we know that that binary compound's only made up of 2 elements, and it's going to break down into each individual element. This could be molecular or ionic, right? And so, but if it's molecular, you'd get 2 nonmetals. If it's ionic, you're going to get a metal and a nonmetal. And again, as always, be mindful of those diatomics. So let's look at an example there, right? So let's say we take some electricity, we pass it through molten sodium chloride, right? So molten just means that we melted the sodium chloride. So we're going to have our NaCl. this case, it's going to be a liquid. And now we're going to decompose that. And so when we decompose it, it's just going to break down into the elements. Now, you would think, okay, we're going to get Na, right, plus Cl. But again, Cl is diatomic, so we got to remember to put that too. Now, hey, what's wrong with this? Ooh, says Lulu. We need to balance that equation. Awesome. So how would we balance that equation? Well, pretty simple, right? 1 Na, 1 Na, 1 Cl, 2 Cls. So we're going to need a 2 there. And then we just change that. We're going to need a 2 there. So that's how we would go about that. All right, so those are the introduction of these two. Tomorrow we'll look at a different type. But remember your daily tasks. Go to the assignments page and complete that. And let me know if you guys have any questions. All right, I hope everything's going well. Peace, love, happiness. Don't miss me too much.